Okay, so we are going to look at the rest of ionic compounds, which are a little bit more complex than what we did yesterday. The only reason they're complex is because they include something called a polyatomic ion. Now, yesterday you should have gotten a list of the polyatomic ions we're going to use in this course. If you don't have that out, you might want to go ahead and pull it out so you have it as a reference to look at the names and the symbols for the polyatomic ions we're going to be using in this video. The next thing we need to understand is what a polyatomic ion is. A polyatomic ion is actually a covalent compound that has become charged through losing or gaining electrons. So in this case, NO3 is an example of polyatomic ion. It actually is covalent, but it has a charge, meaning we're going to see it in ionic compounds. So from there, what we need to understand is what poly means. Poly means more than one. So when we are looking at identifying when a polyatomic ion is present in a compound, we're going to be looking for 3 or more elements present in the compound. So let me show you kind of an example here. Notice this, we have a bunch of compounds. You need to be able to go through and identify whether there's a polyatomic ion present in that compound or not. Well, the way we're going to do that is by recognizing if there's more than 3 or more types of elements. So remember yesterday we just dealt with like sodium chloride, only 2 elements, NaCl. Well, how do we know if there's more than 2 elements? Well, you're looking for your capital letters. So remember each element starts with a capital letter. So NaCl only has capital N, capital C. That has only 2 elements, but check out this guy. B is capital, N is capital, and O is capital, meaning we have barium, nitrogen, and oxygen. There's a total of 3 elements in this compound, so this is a compound containing a polyatomic ion. Okay, so from there you should be able to recognize the compounds that have polyatomic ions in them. So BaSO4, capital B, capital S, capital O, also has a polyatomic ion. Capital B, O, and H contains a polyatomic ion. Capital B and capital O does not contain a polyatomic ion. Capital B and C, capital B and O, capital B and F, capital B, capital C, capital O does contain a polyatomic ion. And again, you can go through and do this with all of these. The important thing is being able to recognize when a polyatomic ion is present and when it's not. So these that do not contain polyatomic ions, if they're ionic compounds, for example, like BeO, that's a general ionic compound, we can name it with our rules we used yesterday. But these that contain a polyatomic ion have some slightly new rules that we have to keep track of. So let's look at those rules. Maybe, there we go. So for complex ions, or for ionic compounds, your cation or your anion can contain or can be a polyatomic ion. So the first thing we need to do is identify where the polyatomic ion is, and that will help us name it. In this case, if we're looking at Na2CO3, sodium is just sodium. But if we look on our list, CO3 is on our polyatomic ion list. It's carbonate. So that means our polyatomic ion in this case is an anion, so we're going to follow the rules for naming the anion based off the polyatomic ions. But just so we know, if it's an element for the cation like sodium, we're going to use the same rules we used yesterday. If it's transition metal, we'll use our Roman numerals. Nothing new there. The polyatomic ions are not changing the rules we've already used. We're just adding new rules to them. Polyatomic ion, if it's the first element, you're just going to name it off your list. Okay. For the second element, or the second ion, if it's an element, you're going to name it like you have been, meaning change the ending to IDE. However, it's a polyatomic ion. Again, you're going to take it directly off your list, and I had that spelled wrong, but that's okay. So in this case, check this out. We have Na2CO3. Our first element, our first substance is an element, meaning we're going to name it off the periodic table and use Roman numerals if necessary. Well, sodium's not a transition metal, so all we need to do is just name him. So just sodium. From there, we're going to look at our polyatomic ion list because we've already identified our second element is a polyatomic ion, and we're going to name it directly off the list. Well, if you look on your list, you're going to see CO3 -2. Well, the CO3 is the name we're looking for, and that is carbonate. So this guy right here is just sodium carbonate. Okay, let's look at another. NH4Cl. So again, the first thing is to identify where your polyatomic ion is. In this case, the NH4 is our polyatomic ion. And again, you'll identify the polyatomic ion by using your list that's in front of you. You're not going to be able to do it off the top of your head right now. Eventually, you'll get very comfortable with them and be able to identify them very quickly. But NH4 is on our list, and that's a polyatomic ion. So if we remember back, if the first element is a polyatomic ion, we just name it. So NH4 on our list is ammonium. So we'll write ammonium. That's our first name. From there, our second element is an ion. And so we're going to name it chlorine and change the ending to chloride. So this guy is ammonium chloride. Okay, check out this guy, AgNO3. Silver is a metal, so we're just going to name him. Yes, he's a trans metal, but remember we don't need Roman numerals because we know his charge. And we know NO3 is our polyatomic ion. If we look at our list, NO3 is nitrate. Okay, now if you notice, we still only have two names, just like if it was sodium chloride, two names. You are only ever going to have two names. If you start trying to name this silver nitrogen oxide, and it has three names, you've done something wrong. So remember to look at your polyatomic ion list if you see those three elements. And again, you should only have two names when you're writing these names. Now, another rule of thumb that we need to pay attention to that adds this new layer with polyatomic ions. When we cross and swap, if we bring down a number, in this case we're bringing down calcium's 2 to ClO3, which is chlorate, we have to use parentheses to denote how many there are. Okay, give you another example. Let's say we are looking at magnesium, and let's look on your list and find phosphate. Okay, well, magnesium is Mg plus 2. Phosphate, if you find on your list, is PO4 negative 3, and that is a capital O. From there, we cross and swap just like we have been. So we bring down the 2, we bring down the 3. So we have Mg3, okay, PO4, and because we're bringing down this 2, we're going to put in parentheses and then put the 2 on the outside, and that's exactly how we would leave it. So when we start naming these, or when you start seeing these weird parentheses things, that's okay. That's just saying we need 2 of them. It's no different than when we did CaCl2 yesterday. We need 2 chlorines to cancel out calciums. We need 2 phosphates to cancel out 3 magnesiums. It's just showing your ratio just like we did yesterday. Okay. Now let's check out this guy. Nickel is a transition metal. Notice the 2 is outside the parentheses, which means that's his charge. So we're going to bring up that 2 and bring up that 1. Now again, I'm bringing up the charge because nickel is a transition metal. I need to know which charge to be able to name it. So Ni plus 2. And then ClO3, notice I'm not touching the 3 because that is chlorate, or that's part of chlorate. I'm just bringing up the 1 and making it a negative 1. Okay, from there we name it as nickel. 2, and ClO3 is chlorate, so chlorate. Keep in mind, the way it appears on your polyatomic ion list is the way it has to stay. I can't mess with this 3 in any way, shape, or form because it belongs to chlorate. That's part of who chlorate is, so you can't touch it. So to give you an example of that type of situation, let's say I have nickel and CO3. Okay, let's write that 3 a little better. Okay, well, CO3 is carbonate. I cannot cross this 3 back up to nickel because it doesn't belong to nickel. It belongs to carbonate. A rule of thumb here to help you out, put the polyatomic ion in parentheses if it's not already in parentheses, just so you don't get confused with that number there. So instead, what we're going to be bringing up are these numbers, which are both 1s. So nickel plus 1, and then CO3 minus 1. And just like yesterday, double check your charge of your anion. Carbonate actually should be a negative 2, okay, which means nickel must be a plus 2 to cancel out that negative 2 charge. So we actually get nickel 2 carbonate. Okay, so going through and naming these. Let's do a couple of these. Let's do that guy, and we already did one of those, so let's do this one. Okay, so notice in the first one, and again, we'll put them in parentheses just so we get used to seeing them. And again, it just helps you be able to see where they are. So both NH4 and ClO3 are both polyatomic ions. Well, that makes our life easier. We just name it. So NH4 is ammonium. Whoops. Let's try that again. Ammonium. There we go. And ClO3 is chlorate. Okay. For the next one, we have iron and already in parentheses nitrate. Well, iron's a transition metal. I need its charge, so I'm going to uncross and unswap. Bring up the 2, bring up the 1, and I get Fe plus 2 and NO3 minus 1. Again, notice I'm not touching that 3 at all. I'm just playing with what's outside those parentheses. Well, iron plus 2 and nitrate minus 1. Double check your anion. Nitrate is supposed to be a minus 1 based off our list. So we're just going to name this as it stands. So iron 2 nitrate. Okay, and again, already in parentheses makes our life easy. NH4 is ammonium. Okay, and oxygen becomes oxide. Okay, so that's for naming. Now, let's take the names to the compounds. Thankfully, it's no different than what we did yesterday. We need to write out the ions. So sodium is Na plus 1. Notice this ATE at the end. Our elements off the periodic table, if they're an anion, should always end in IDE. So the fact that we see ATE instead of IDE, that tells us we are dealing with a polyatomic ion. So that's your first indication when looking at the name to know to look at your list instead of the periodic table. So if we find phosphate on our list, we get PO4 minus 3. Okay, we'll treat it like we had been. We'll cross and swap. Again, not touching that 4, and if it helps, put it in parentheses so you know not to touch it, because that belongs to phosphate. So we get Na3, PO4. And if it helps, go ahead and put it in parentheses just so you see that that's part of the polyatomic ion and not a charge. Okay, let's look at another. Whoops, sorry, I skipped one. Aluminum carbonate. Well, aluminum's Al plus 3. Carbonate again, ATE tells me periodic polyatomic ion instead of periodic table. And that's CO3 minus 2. And again, if it helps, let's put it in parentheses. Cross and swap my charges, I get Al2, CO3, 3. Okay. Notice this one, manganese 3. Remember that 3 belongs to the transition metal. It is our charge of the transition metal. Nitrate tells me ATE. Tells me polyatomic ion, so NO3 minus 1. Cross and swap. And I'm going to get MN1, which I don't show, and then NO3, and because I'm bringing down a value, I'm going to put it in parentheses and put the 3 on the outside. Sometimes this can get confusing when there's 2 3s. Please remember the first 3 belongs to nitrate. The second 3 is how many nitrates you need. So just make sure you don't cut one of those off because you feel it's repetitive. It's not. It needs to be there. Okay, let's try a couple of these before we finish. We'll do the first one, and let's do that guy, so we can go through and do these. So beryllium nitrite, again, ITE tells us polyatomic ion versus periodic table. Well, beryllium is Be plus 2. Nitrite, if we look on our polyatomic ion, is, oh, sorry, not NO3, NO2, negative 1. Cross and swap, we get Be, NO2, 2. Okay. Ammonium carbonate, same thing. Ammonium is a polyatomic ion. It is NH4. And let's just go ahead and put in parentheses to help us see this, plus 1. Carbonate is CO3, negative 2. Okay, so we'll cross and swap our charges. And we're going to get NH4, 2, and CO3. And you're welcome to put it in parentheses if it helps you see it. Okay. Other than that, that's it for polyatomic ions. So we haven't changed the rules that we were using yesterday. We've just added to them. So don't forget the fact that if there's not a polyatomic ions, we stick with the same rules. If it is, we use our new rules. That's it.